Hello and welcome to Pavilion's webinar, Microsoft SQL Server, Virtualization and Application Performance. Customers can have it all. My name is Walter Hinton, Director of Product and Solutions Marketing at Pavilion, and today I'm joined by Keith Parker, also Director of Product and Solutions Marketing. Hey, Keith.
Hey there, Walt. Thanks for having me. Really appreciate it.
My pleasure. So our agenda today is to walk through what's important to Microsoft SQL users and customers, why virtualize SQL Server, what are some of the technologies that can significantly accelerate SQL Server, like NVMe over Rocky, some of the benefits to SQL Server, and we'll also talk about some real-world customer results. But Keith, I know you've had a chance to talk with various users and learn more about SQL Server and storage, but what does Microsoft do?
Well, that's a really interesting question because, Microsoft obviously produces MS SQL, and so they have a pretty good handle on what is needed to actually drive performance there. And when you look at the documentation they provide, it's pretty clear. Here's one example of what Microsoft says in their documentation. There's the link so any of our viewers can go and see it yourself. And according to Microsoft, performance issues are typically not caused by high resource utilization. So it's not the processor is oversaturated. It's not there's not enough memory. It's directly related to the configuration of the storage subsystem. And that particular document goes on to say, storage configuration is one of the critical components of a SQL Server deployment. So, database servers tend to be heavily I/O bound due to read and write activity. And one of the things that I thought was really important and really surprising to me, if you will, is the I/O behavior pattern of operations matter is typically 80% writes and 20% reads. So having that properly configured is so critical. In fact, they have some other documentation that goes on to say that understanding SQL Server and IOPS is really, really important. So, again, more Microsoft documentation. So this is straight from the source. It says any server that hosts a SQL Server instance, it's important to achieve the fastest possible response from the I/O subsystem. So it's all about IOPS and low latency on your storage. So they go on to say you can't add other resources such as CPU or memory to compensate for slow response from your I/O subsystems. Those things can influence performance across your implementation, but really having the right storage that can provide the performance that SQL instance needs is so incredibly critical.
I never would have thought about 80% right, but makes perfect sense to me now.
Yep, absolutely. And in fact, when you look at it, according to Microsoft, what is truly critical to SQL performance? It's going to be three things. It's going to be high IOPS, it's going to be the lowest possible latency, and it's going to be write performance. IOPS, latency, and write performance. Those are the things you need to really key in on your storage solution to make sure you can get the best possible performance from your SQL implementation. And yet, despite all of that, because performance matters, when you go out and you look at customer implementations, you look at how people are actively using SQL today, what kind of environment are they going to have? Well, odds are pretty good it's going to look something like this. You're going to have one or more of these basic configurations. You've got some servers clustered together talking to direct attached storage. Maybe it's SAS attached, maybe it's over, a direct attached, Fibre Channel and Direct Connect, or you've got some type of fabric setup, probably Fibre Channel, maybe iSCSI, might even be InfiniBand. The infrastructure doesn't really matter. The fact is you're going over some type of fabric to try and attach to SAN storage, really. Or you've got more of a direct attached configuration. You've got a number of servers with direct attached disks, and those are all going to be using some type of software to have a converged infrastructure where you're adding nodes when you need to scale and things like that. And that's what your databases are going to look like. But when you look at the rest of the data center is going to look something like this. You've got all of your servers aggregated together with, a hypervisor, probably VMware running on top of it, and virtual machines running on top of that. And that's what every other application looks like. But because performance matters for SQL, your databases are the things that don't look like that. And when you look at it, every other application is going to run on a hypervisor. So,
Yep.
maybe Walt, maybe you can talk a little bit about, why that is.
Wow. It's fundamentally easier to manage. I can orchestrate. I can do failover. I can do clustering. I can do live migrations. I have high availability and perform replication, and all of that from a single pane of glass. So think about admins out there. If all I'm doing is dealing with SQL Server storage, okay, but I'm doing a lot of other things. And would it be great if I could run SQL Server in a virtualized environment?
It absolutely would. And, this all begs the questions, what if,
Right.
what if you could double your VM performance? And what if you could do that with half the latency? Think about what you could achieve by doing that. If you could accelerate your applications, your virtual machine performance, if you could cut your latency, that means you can do more with the hardware you have. And that means you can slash your license fees. And, whenever you're doing this, what are some of the challenges with VMware? Well, you're going to have all this software licensing fees. You're going to be licensing it per core. You're going to be licensing it per system. You're going to be, using all those resources. And you can shrink your storage footprint. I can cut down on the number of servers I have. I can cut down on the networking, on the management, on everything that goes along with that. So I can get better application performance. I can cut my networking costs, and I can increase my throughput. What if I could do all that?
Well, but how, right?
Well,
It's Fibre Channel, maybe. iSCSI, probably not. So what kind of way might we tackle this problem?
Well, the way you can really achieve this is with really what's the next generation interconnect, the next generation interconnect for storage, and that's going to be NVMe-oF. So NVMe-oF takes the NVMe protocol, which is the drive protocol that really enabled SSDs to achieve their potential. It's going to extend that over a fabric. So that's really important, because when you look at how data was connected over fabric historically, you're going to have your drives, and they could be, doesn't matter, SSDs, disk drives, doesn't matter. They were going to talk one particular protocol. Could be SAS if they're hard drives, NVMe if they're SSDs, whatever it is, that block level data is going to come off those drives, and then it's going to get encapsulated into whatever the protocol the network was using. So if it's Fibre Channel, it's going to get encapsulated in Fibre Channel. If it's iSCSI, it gets wrapped in Ethernet. Whatever it is, it doesn't matter. The point is, you're taking that block data, you're wrapping it in another protocol, sending it out over the network, and when it gets to its destination, that data is going to have to be unwrapped, turned back into block level data, and then provided to the application or whatever's requesting that data. Now, one of the things we talked about is latency, IOPS, latency. And every time you're taking all those steps, it's adding latency, it's adding steps, it's adding overhead, it's reducing your performance. So if you can maintain that one protocol across the network from end to end, that's going to be a huge benefit. So that's really going to enable that end-to-end NVMe data connection. And one of the things that's really cool about NVMe-oF is the F is, OF is over fabrics, and it can run on all kinds of different ones. It can run on Fibre Channel, it can run on Ethernet, it can run on InfiniBand, and there's all kinds of different ways to do that. So what we can do is look at, okay, what are the strengths and weaknesses of each of those, and what's going to be best for SQL in VMware environments. So what we really need is, we need the way that's going to provide the highest IOPS and the lowest latency from point A to point B, essentially. So when you look at Fibre Channel, Fibre Channel's been, the predominant SAN interconnect of choice in the enterprise for decades. Not the only one by any stretch, but certainly, probably the most common, at least in the enterprise. Yet Fibre Channels, as a technology, it's kind of run its course. There's the latest generation of it is 128 gigabit, which, for all intents and purposes is, a unicorn. It doesn't really, very, very few places actually have that. Most
Right.
most installations are probably 16 or 32 gigabit.
Mhm.
And it's still encapsulating that NVMe data. What it does is it extends the life of the Fibre Channel protocol. So people using Fibre Channel can continue to use it. But if they want to achieve that better performance to really get the benefit of NVMe, they're going to have to upgrade their Fibre Channel infrastructure, which means, I'm ripping and replacing my HBAs, my storage, my switches, everything. And
Yeah.
yep, you're exactly right. That is expensive. Now there's good old Ethernet, TCP. Absolutely. It extends the performance of Ethernet. Right now, 400 gigabits per second is the latest iteration. And like Fibre Channel, there's not a lot of 400 out there today. Just like Fibre Channel, there's not a lot of 128 gigabit. But you know what there is out there? There's 100 gigabit, there's 40 gigabit. Any way you look at it, whether it's the top performing available today or the most common available today, Ethernet is going to be significantly faster than Fibre Channel. And NVMe uses it just like any other fabric. It can transport that data across there. So it really enables you to use that common Ethernet infrastructure. InfiniBand, InfiniBand has been a primary technology in high performance computing environments, places where you need extreme low latency, reliability, and it continues to be a leader in that industry. And absolutely, InfiniBand's a great choice to go ahead and use NVMe-oF. Just like Ethernet, current is 400 gigabits per second, and it like Ethernet, it has a long road ahead of it. But what might be the most interesting is Rocky. So Rocky is RDMA over converged Ethernet. And essentially what that means is it's all the benefits of Ethernet, high performance infrastructure, readily available, lower cost because you've got economies of scale when compared to something like Fibre Channel.
Sure.
But it adds in RDMA. So you can do remote DMAs. And effectively that means you're able to bypass the CPUs when you're doing data transfers. Typically when data comes into a system, the CPU gets interrupted so it can move that data where it needs to go. With RDMA, data is placed directly into memory for the application that requested it without need to interrupt the CPU. What that means? Low latency, fewer steps, lower latency, dramatically lower latency. And effectively what that gives you is the ability to have external shared storage that has the same and in some cases better latency than direct attach. Think about that. You can get the benefits of external shared storage. So scalability, manageability, flexibility, all the things that go with that. And you're doing it with better performance than NVMe drives inside a server. That's amazing.
So I think you've got a picture coming up here that talks a little bit more about RDMA-enabled networks.
Absolutely. So this is really talking about NVMe over Rocky, or again, RDMA over converged Ethernet. And it really talks about, the ability of the storage or the server to transmit data over the network without interrupting the CPU. So where that really plays into the topic of today's conversation is around eliminating the VMware performance penalty. Now, there's one story I like to tell. So I don't want to say who, but I used to work for someone who, if there's a Mount Rushmore of people in the history of storage, this guy's on there.
Hmm.
I mean, it cannot overstate the impact this person has had on all storage technologies. And absolute genius, huge impact. But one place he had a huge swing and a miss is when I worked for him. It was in the early days when VMware was first gaining traction. It's because I'm old. And we could not convince him to allow us to put the engineering resources into supporting VMware, because he just couldn't wrap his head around why someone would use VMware. Because his view, and clearly history has proven him wrong, but his view was that VMware consumed so many resources that it wasn't worth doing, that you'd be better off just clustering your servers together and getting your benefits that way. Now, obviously, the market did not agree with him, but that doesn't mean that he was wrong about the VMware performance penalty.
Right.
VMware does take a lot of cycles, and that's why when we talked about what your infrastructure looked like, your databases, your SQL is running in one type of environment, everything else is running on another, because your databases need high IOPS, low latency, and write performance.
Yep.
And Rocky really helps free that up. It really helps solve that. It gives you your CPU cycles back so that you can apply them to your applications. In this case, SQL. You can run VMware, you can get better application performance. And at the end of the day, what you're going to see is by using this technology, you can run VMware on your systems, run SQL on VMware, and get the same or better performance than you're getting on bare metal. So you can actually get an improvement with VMware compared to running on a bare metal. And that's a game changer.
So admins can finally go home on the weekend.
Exactly right. Imagine that.
Well, I know Pavilion was one of the very first day one certified solutions for vSphere 7. And vSphere 7 from VMware is actually what enables Rocky to be used and to take full advantage of the performance characteristics as well as the manageability you get from VMware. But what about the performance aspects here, Keith? How does say Rocky compare to iSCSI as an example?
That's an interesting question, because when you look at iSCSI and Rocky, they're going to run on the same Ethernet infrastructure. So
Right.
If you can run both on the exact same hardware, what's the real difference? Well, unfortunately, some testing's been done on that. Now, this was not testing that Pavilion did. This was testing that NVIDIA did. This was, NVIDIA in conjunction with VMware did testing on Pavilion hardware, because one of the things that we really enable is absolute simplicity of use in choosing what protocols you're going to go ahead and use. So moving from iSCSI to Rocky on a Pavilion array is 2 mouse clicks. So they were able to do these tests on the exact same identical hardware, click the mouse a couple of times, change the protocol, ran the same test. So could not be more of a fair test. And what they found is, on vSphere 7 running the exact same hardware, by comparing iSCSI to Rocky, they got more than twice the read IOPS and less than half the latency. So what we talked about is IOPS, latency, and write performance. So just by moving from iSCSI to Rocky, more than doubled your read IOPS, less than half the latency. Write, we all know write has greater overhead than reads, but they were still able to get 1.5 times the write IOPS at 61% the latency. So massive performance improvements. The result, they could run twice as many virtual machines at half the cost, because you're cutting your hardware cost, your networking cost, your management cost, your licensing costs. Double your virtual machines, cut your costs in half. They could run more machines at half the latency. They could do twice the IOs at half the latencies on the same VMs. And they got massive improved bandwidth for your high performance app workloads, such as AI, ML, analytics, all these things that are being supported today. So moving from iSCSI to Rocky, again, identical hardware, no physical changes at all, more than doubled your throughput, your read IOPS, half your latency, huge performance improvements.
Wow, just wow. So in thinking about customer environments, and this is a very typical one that I see many times, you wind up with islands of virtual machines. You've got some combination of SAN and direct attach, maybe iSCSI, easily hitting a petabyte or more of virtual data, and then production databases that are not virtualized, spread across multiple different storage arrays. And the customers that I talk to certainly want to move to containers. So what if everything could change? What if you could do this consolidation, taking advantage of vSphere 7, taking advantage of higher IOPS, lower latency, write performance, fewer islands, lower maintenance expenses, faster VMs and applications, fewer software licenses potentially, or take advantage of the software that you have and make it more efficient, and move to containers. So Keith, talk a little bit about how Pavilion makes this happen.
Well, I'm glad you asked, Walt, because Pavilion really enables this because we have a completely unique architecture. Now, when I say unique, I don't mean specialized proprietary. Everything's built on on standard technology. But what we do is we fundamentally reimagined what a storage solution should look like. And typically for the last 20 plus years I've been doing storage, every storage solution has been the same fundamental architecture. The protocols and technologies and things involved, but the fundamental architecture never did. And that was that dual controller architecture. And Pavilion went back and said, what if we built it on a network switch, the fastest thing in the data center? And so we designed this like a switch. And that high throughput switch, high performance switch, enabled us to connect not just dual controllers, but 20 independent storage controllers in a single array. So think about that. You're getting all the performance, all the horsepower, all the benefit of what would otherwise be 10 storage arrays all in one storage array. You're getting that kind of horsepower, and you're able to support massive scale with up to 72 drives. On the back, you've got massive connectivity, 40 100 gigabit connectors or 10 200 gigabit connectors. So this really gives you a multi-controller, multi-system solution within a single array. What does that really do for you? Well, that's going to enable you to have any-to-any drive connectivity. So you've got high performance, high reliability. It's cashless. We don't have to pack our box full of high cost DRAM or SCM to artificially inflate our read performance numbers. Because we have 20 controllers, we can write data in parallel to drives to achieve high performance. We support DMAs from any drive to any controller for extreme low latency and RDMA across the network. And essentially what this all means is users get an incredibly dense, incredibly performant solution in a very compact solution. So we give them performance, density, scalability, and flexibility. And every one of those are in levels that are really unachievable by any other solution out there. So what kind of results are we really talking about? Well, let's go back to what we talked about we needed. So SQL implementations need high IOPS. Well, a single Pavilion solution, each individual box can give 20 million read ops and 5 million write ops. And again, right IOPS are very, very important. Latency, we have incredibly low latency, 100 microsecond read latency and 25 microsecond write latency measured at the host. And I just really want to take a second and talk about that last part there, because almost every vendor out there, when they publish their latency numbers, what they're talking about is from the time the IO request was ingressed, so when it hit the back port on their system, to the time it was fulfilled out the back port. It is the latency within the box. When Pavilion talks about latency, we are talking about latency measured at the host. So all the latency in the box, and then putting it back out on the network into system memory of the host that made the IO request. So we're not just faster, and I mean significantly faster. Typically you're going to see latency numbers of between 1 to a half a millisecond. We're in the tens and hundreds of microseconds. So orders of magnitude improvement. And we're not just faster, we're faster over a longer distance. And then comes write performance. Because of our multi-controller architecture and the way the system designed, we can achieve unparalleled write performance. We're able to achieve 90 gigabytes of write performance from a single array. And that scales linearly as you go across systems. So when we talk about write performance, we're talking about extremely fast write performance. And when you look at other vendors out there, the rule of thumb is most of them don't even publish the write performance. Exactly. And that's because it's a small fraction of their read performance. Don't get me wrong. I mean, I would love to see them go out there and publish their write numbers, but they generally don't. And there's a reason for that. I just can't believe there's, marketing teams across all these vendors going, those are great numbers. Let's not tell anybody. I have to believe, I have to believe that, there's a reason they're not publishing them. So whenever you're looking at a storage solution, always look at the write performance, because that has become more and more important to not just SQL, but really every application across the board.
Absolutely. So let's talk about some of the benefits that this solution brings for SQL Server specifically. I can accelerate queries and searches. You talked about how low the latency is. I've got incredible throughput for report generation. I can do very large data sets, up to 2.2 petabytes in one of these Pavilion systems. Support other workloads and applications. Reduce potentially license fees by reducing IO weight and running faster than you ever have before. We also have a Windows WCL certified NVMe-oF driver for those applications or those database requirements where bare metal really is important. And this is one of those things where Microsoft hasn't quite released NVMe-oF for Windows. So we've written a piece of code ourselves, certified by Microsoft, supports persistent reservations, clusters, virtualized clusters, and of course we run snapshots and backups with zero footprint, meaning you can take an image of your database at any point in time and fall back to it as needed.
That's really great. Well, maybe you could talk a little bit about what are some real world examples of customers that have actually used this technology and what kind of benefits they've seen.
Yeah, so let's take a look. First, we'll talk about a group in the Netherlands called Statistics Netherlands. They also go by CBS. And kind of their world before Pavilion came upon the scene was thousands of VDI instances and hundreds of SQL instances, massive VM farm, and multi-petabytes in scale. They had a variety of different solutions, but the real challenge was IO bottlenecks. So not only did they need to have 50 IOPS at less than half a millisecond per virtual machine instance, they also needed to be able to drive up their utilization of SQL Server, load SQL Server instances into VMs, and deliver performance that they were typically getting with bare metal. So Pavilion came in this kind of after picture, reduced latency using both NFS and NVMe over Rocky. We gave them flexibility with not only file storage, think NAS, block storage, and object storage. We were able to give them 500 IOPS at less than half a millisecond, did a massive consolidation of VMs, reduced the number of licenses that they needed, and moved them into persistent K8 using our container storage interface. So great quote from the product manager there. One storage platform to meet all our needs. It's super fast and still economical for non-performant workloads as well. And kind of the biggest quantifiable benefit. So this is a public entity. They do all of the statistics gathering for the Netherlands, report on health and other things. So they had to go out to public tender. The leading alternative was 2 full racks of gear with 2 million IOPS, 8 gigabytes a second, and well over a millisecond of latency. Pavilion proposed 1.5 systems, so taking up roughly 8 rack units, not 2 full racks, with 40 million IOPS, 180 gigabytes a second of throughput, and 40 microseconds of latency. And that's read latency. Write latencies, as you mentioned before, in that 20 microsecond range. So just a radical transformation for this organization.
And that wasn't even 2 fully populated arrays. So they have the ability to scale up within the system they have if they ever need to, right?
Absolutely. It was 1.5 was
Wow.
what we proposed. And yes, I think at this point they've filled up the second one and are ordering more. So it's been a really good customer experience. And boy, what a story here of just looking at performance and density compared to a very popular, well-known brand.
Yeah, that was, correct me if I'm wrong, but that's not just an extremely well-known brand. That was the incumbent there. Is that correct?
You are correct.
Wow. And,
Yeah.
we were really able to come in and in 1.5 systems deliver more than 10 times the performance.
Yeah, amazing. So let's look at another.
At less than 8 times smaller, and probably one of the more important one, 5 times lower cost.
Yeah.
Pretty nice.
Yeah. A really good story. So let's look at another one. This is a healthcare company, and they had an existing SAN. And it was at that point where, do I go from 32 to 128 gigabit? How much is that going to cost? What's my return on investment from that? Am I going to be able to reduce licenses? Can I shrink my footprint? So they looked at doing a refresh with their SAN. They looked at doing direct attached storage because they needed the performance for their production SQL database. This organization during COVID turned out more product than they ever had in the history of their business. And they were able to do that with a radical improvement in database performance. So obviously they went to the far right-hand side, chose NVMe over Fabrics. And here's kind of how they thought about the problem. So when you look at NVMe over Fabrics and you look at the stack, and let's compare the stack on the left to the stack on the right, in iSCSI, I'm going through all kinds of layers to move data from a host to an array. And we showed you earlier the improvements in IOPS, both read and write, and in latency. And basically that comes from this picture on the right, which is I've removed 6 steps in the data movement protocol. So what happens? Better performance, increased VM density, reduction in physical sockets needed, and ultimately for this shop, they reduced the amount of software that was required.
And it wasn't just the software, it was the software licenses.
Yeah, in fact, I think if you flip to the next one, Keith, you may want to just kind of talk through this.
Absolutely. So what they saw is by moving from their existing solution to their newer ecosystem, they were able to dramatically improve their environment. So they essentially went from 10 ESX servers down to 5, which also cut their number of sockets in half from 20 to 10, the number of cores from 640 to 320. And for licensing purposes, that is incredibly impactful. They completely eliminated the use of Fibre Channel HBA, so they did not have to upgrade any of those expensive devices. They did have to double their number of NICs, but compared to the cost of a Fibre Channel HBA, it's pennies on the dollar.
Yep.
Same for Fibre Channel ports, so networking ports. Again, moving from Fibre Channel to Ethernet, there's no cost comparison. So going from 20 Fibre Channel ports to 0 and 20 Ethernet ports to 40, huge financial benefit. Licensing was cut in half. Licensing for VMware was cut in half. Licensing for applications was cut in half. And essentially what they were able to achieve is they got universally unmatched storage, performance, density, scalability, flexibility, and reduced latency by 78%, increased throughput by 81%, and increased their actual density by over 100%. So massive, massive benefits for this company.
Yeah, but don't just listen to us. Here's what the customer has to say. We are able to run more virtual machines on our existing infrastructure. With respect to storage management, we've reduced the amount of work that was required. We probably had 3 people spending between 25 and 50% of their time doing storage-related activities. Whereas now we have 1 person spending perhaps 10% of their time. So this speaks to how much better things are when you can run them in a virtualized environment. And you saw the benefits financially and from a performance perspective as well.
So yeah, I think the net is, all of these customers were able to simplify their environment, improve the performance of their applications, and increase their manageability and reduce their costs. And at the end of the day, the cost reduction alone more than paid for the storage that enabled them to do all of that. So
Yeah.
Effectively, the storage was free, and they got all those benefits for it. So pretty clear return ROI on that investment. And with that, I think we'd like to go ahead and take some questions from the audience. If any of you do have questions, please feel free to go ahead and enter them into the chat, and Walt and I will go ahead and answer them to the best of our ability. And in the meantime, I believe we do have a couple of questions that have already come in. So it looks like the first question is, you talk about high write performance, but why is yours different? So I'll go ahead and jump on that particular one. So write performance is going to be impacted by a number of different things. Anytime you look at performance in an array, what most vendors show is they show write performance. And they do this by putting a lot of DRAM or SCM, storage class memory, into their array, which they then read sequential data out of. Now, what that does is that shows a really high rate of IO, read IO in this case, and that's because it's all coming out of DRAM. It's all running super fast. That's not representative of what performance is going to be from the drives, whether they're disk drives or SSDs. So it tends not to be that representative of a number, but that's the quote unquote hero number that most vendors publish. When you do writes, Well, you're not reading from DRAM, so it's not going to be as fast. So right there, you get a huge performance delta in the performance you can expect to see. The other thing that plays a big role is whenever you're doing writes to storage, there's typically some type of data protection scheme that goes on. Now, this could be right using RAID to protect the data. It could be using erasure code. There's lots of different ways to do it. And every one of those is going to add some amount of overhead, in some cases, a great deal of overhead into that write process. So all those things are going to add up into and create a huge penalty in write. And that's why there's such a big disparity between read and write performance for so many vendors. Pavilion gets around that in a couple of ways. Pavilion, because we are a switched-based multi-controller solution, we're able to put the processing power of multiple controllers in there. So for example, in a standard dual controller array, when you have a write happening, you've got one processor on one controller performing all of the RAID calculations that have to happen for each block of data before it's written to the array, regardless of how it's striped. With Pavilion, you have multiple controllers that are doing it. So we're able to do that much more efficiently, much faster. So instead of having one controller doing it, you'll have, several, maybe, 5 controllers doing it. So you're going to get a huge performance increase in that write performance. The other thing is we're a cashless system. Because we don't populate our system full of cache, we're able to have much more representative numbers of the performance that's coming both in reads and writes. So you're not artificially doing it through caching. So our numbers are both going to be really representative of what customers can expect to see, as well as extremely high performance. So that's why we have such great read and write numbers across the board. All right, looking at the next question. It says, you mentioned per array of performance, but what if I need to scale out? Well, do you want to go ahead and talk a little bit about that?
Sure, Keith. So we scale in a linear fashion across chassis. A good example here is with our HyperParallel file system, we can ingest data at speeds as high as 56 gigabytes a second and read data back at speeds as high as 90 gigabytes a second. So take that and basically just extend it across chassis. You're talking about 112 gigabyte read for 2 chassis, 180 gigabytes of, 112 gigabytes per second of write and 180 gigabytes a second of read access. So across chassis, we span in a linear fashion. The global namespace also expands across those chassis. So single global namespace to allow users to share. And then depending on what type of client you're connecting to, your performance may vary, but we've seen extraordinary results with things like the Gluster.
Great, thanks so much, Walt. All right. And see, the next question is, isn't Fibre Channel better for critical applications since it is lossless? And do you support Fibre Channel? And I'll go ahead and talk about that a little bit. So, Fibre Channel has been the dominant storage interconnect throughout the enterprise data center for decades, really. And one of the reasons for that is that it's been a secure, lossless protocol. So that's definitely been one of the things that has driven its adoption. And in the early days of iSCSI, one of the big knocks against using Ethernet as your storage backend was that it was a lossy protocol. You couldn't guarantee that packets wouldn't get dropped. But that's not really the case any longer. With the advent of converged Ethernet and modern networks, it's absolutely a lossless connection and not something you're going to have an issue with. So that absolutely was a concern in the early days of iSCSI, especially 1 gig iSCSI, but that's long since ceased to be an issue. Now, as far as Fibre Channel, Pavilion supports Ethernet as well as InfiniBand on the Pavilion HyperParallel data platform. And the reason we support those protocols is simply that those are the ones that have the roadmap going forward. Fibre Channel is really at the end of its roadmap, and is even the latest generation lags far behind what you can expect in performance from Ethernet and InfiniBand. So we're 100% behind those technologies because those really are the storage interconnect of the future. Consider the latest and greatest Fibre Channel, 128 gigabit. That even that new, modern, latest, greatest standard is far behind the latest Ethernet and InfiniBand, which is 400 gigabit. So clearly, Ethernet and InfiniBand are the road forward, and that's where we're focused. All right, let's see. We got another question. It says, you mentioned that CVS is running NFS and Rocky. Can you have both protocols running simultaneously in your system? Walt, do you want to go ahead and talk a little bit about that?
Sure. Yeah. In fact, we can support 3 different storage protocols: block, file, and object. Object with S3, file with NFS, and various formations thereof, 3.0, 4, NFS v4, Gluster. We also even have a Hadoop and a Spark plugin client for our file system. And of course, you can run block. That's where we got started. That's by far the most performant way to do things. And in many ways, how CBS was able to achieve their massive consolidation at scale was to use our block protocol and then augment other parts of their workflows with file and object. But of course, all 3 in one, universal storage with most performant, dense, flexible, and scalable platform that's out there.
That's great. Thanks so much, Walt. And it looks like we have one last question, which is, I know this is about VMware, but what about Hyper-V? And so, yes, this was a VMware presentation, but when you look at organizations around really around the world, what you're going to see is you're going to see very few shops that are 100% VMware and 100% Hyper-V or 100% Zen Server or whatever it may happen to be. You're going to have a mix. There's going to be a lot of VMware and maybe a few Hyper-V or vice versa, whatever the case may be. So Pavilion absolutely 100% supports Hyper-V. We have WCL drivers to support that. We are fully supported in a Microsoft environment, including with NVMe-oF, and we're absolutely able to achieve high performance in those types of environments. So 100% support for Microsoft Hyper-V, and you can expect to get similar performance in that type of environment as you would in VMware. And with that looks like the last question. So I would like to thank everyone for attending today. If you do have any questions or would like some more information on the Pavilion HyperParallel Data Platform, please feel free to visit us at pavilion.io. Thank you.